So I thought I could share. I was doing OpenGL and I was trying to learn computer graphics. So I feel like I'm starting out, but it feels like there is quite a lot of things to learn. And what I was thinking about in computer graphics, there are a couple of stages that the stuff goes through. So here I was aware that there are some stages that we can program, and here this is OpenGL specification, and here I saw that we have vertex processor, tessellation, geometry fragment, and compute processor, and that made me think, wait, can I really program all these 6 steps of OpenGL that it does? And it turns out, yes, I can write code for each of these, and each of these serves different purpose. Now, I don't know what exactly, I'm not familiar with that, I have never used them, but I find it quite intriguing and quite interesting. And so I read these things, what they are for. So what I got out of it is that compute processor is great for parallel computing, because we are doing computing on GPU. And fragment processor, I don't know, but I think it's for colors, at least in simplified way, from what I get about it. Now I have absolutely no idea about geometry processor, and as I said, I never used this before, and I find all of this really new. Tessellation is also new, but I heard that word before, but again, I don't know what it's used for. And it seems like there is another one also for tessellation, but they're for different purposes. This is tessellation control, and this is tessellation evaluation, and yeah, I don't know. And here we have vertex processor. Now I already knew about vertex shader and fragment shader, and I knew that they were used for different things, but I didn't know about these. So this exploration and reading of various articles online, I find it quite nice. Then I'm not sure what else to say, so I'll just stop here. Also, this document was nice. I read it briefly. I didn't read everything. I mean, you can see here it has 238 pages. I'm not I'm not gonna read it all. So I found that interesting. I was reading this document because I was curious about the features of glsl for 4.60, but it turns out I didn't get anything out of it. I mean, I did. I found out about this overview of shading, this sorry for the finger, but this is actually nice. I mean here, let's look at here. So here we can see that I guess these are characters and phases. Yeah, I guess this is what we are allowed to use to type. I guess syntax. I guess we can call it syntax. I don't know. And what's this? I guess these are the stages. Makes sense. Makes sense. I guess these are the stages. I guess it's nice to know. I'm gonna read it after. Source strings, no idea. Preprocessor, right? So it has preprocessor. Right. It's like similar to C++ standard processor. That's nice. That's nice. I saw those. So we have. I think here we do version. That doesn't look like, yeah. That's right. That's preprocessor directive. I thought it was familiar. So it that's looks like that's related to C++. So looks similar. And that's nice. I had no idea about that. Source string preprocessor comments. So comments are like C or C++, right? Tokens, keywords. Yeah, actually, this is a really good idea to just briefly check what's available in these. I'm sure I will find that useful eventually. It has quite a few. All right, identifiers. Definitions, bloody alarm. Then basic types, scoping, storage, layout, interpolation. Here memory, specific order of, yeah, looks, operators. I mean, it looks like a whole different programming language. Constructors, matrix components. Right, it looks like a whole different language. Expressions, vector and matrix operations, out-of-bound access, statement, function. Right, so we also have function. All right, looks good. Selection. I see, and since that runs on GPU, it's nice because GPUs are really fast today, according to the things that I've read. So we can do computation on GPUs, iteration, right? So we also have loops, for while, do while, jumps, built-in variables, gl, vertex, instant, draw, base, position. I saw this one, it's a common one, common in tutorials that I did. Compatibility with profile, vertex, shader, built-in constants. We also have built-in constants, uniforms. I guess it's nice to see. The more you see, the less blind you are, and the more you see, you see nothing. Angle and trigonometry functions. I guess that's important because in shaders we will do a lot of math operations on vertices. I guess that's important. Common floating point, subpass, input shader invocation, shader grammar, lexical analysis. It looks very like a useful document to read, but I'm not gonna read it all. Basics. Yeah, looks good.